Hello students, welcome to the course on Machine Learning Foundations. I am Harish Ramaswamy and I am one of the 3 instructors who is responsible for teaching this course. The first week we will take a brief look at the basic terminology and introduction of this course and set up some problems which will be alluding it throughout the course. First, here is a brief outline of the content for this week. The first question that everyone should be asking is, what is machine learning? You might have heard of this term bandied about in the press, in the newspaper, in the TVs, but what is machine learning? According to Wikipedia, this is the definition that you can find in Wikipedia. It says machine learning, or which is popularly abbreviated as ML, is a study of computer algorithms that improve automatically through experience and by the use of data. This is a pretty concise definition and it does a pretty good job, but it uses more terms than can be understood easily. For example, what is a computer algorithm and what do we mean by improve automatically and what exactly is the use of data. These terms are not fully clear even though they are reasonably approximately clear. So, we will throughout the rest of this course we will make these terms clear. Before we even make that attempt to impress upon you the importance and the ubiquity of machine learning tasks, even before coming and watching this video today, you might have performed several machine learning tasks. I will give 2 examples. One example might be weather prediction. You might have just after you woke up, you might have just googled what is the weather now, and Google or some other weather site might have given you an output like this. While machine learning is by no means the only tool that is used for giving weather prediction, it is a major reason why weather prediction is so much more successful these days than let us say 20-30 years ago. Here is one other example of a machine learning task that you might have performed today even before let us say watching this video. Let us say you wanted to take a group picture of your friends and family, and any reasonably advanced camera software these days would automatically detect the faces in the group of people, and it might put boxes so that it is easy for you to focus, it is easy for the camera to focus. And autofocus would automatically focus on the faces in the image, because most people who take pictures of faces want the faces to be in focus and not the background. Machine learning is an important and in fact the most important tool that is used for doing this kind of task. I have been saying the word task several times over and over. What do we mean by that? Task has an English meaning that is but when we say task, we mean it in the sense that a task is a process which converts an input into an output. That is the notion of abstraction that we will be working with. A task is something which converts an input to an output. So, a task can be performed at various levels. The lowest level is the level of manual labor, where a human directly operates on the input and converts it to an output, right. So, that is the lowest level of that any task can be performed at, that is a manual labor. One level above that you have tool usage, where the human does not directly operate on the input to create the output, but rather the human constructs a tool which in fact operates on the input and converts it into the output. A special case of tool usage is simply programming, where the tool happens to be a computer and the way the human creates a tool is typically through programming and software. Then you have the next level of abstraction, which is machine learning. Here the human actually does not even build the tool himself. What the human does is actually just give a broad blueprint to a tool design box, which in fact constructs the tool. It also uses an additional source of data along with human inputs to make the tool. So, you can clearly see that the higher up you go, the level of abstraction is increasing. At the lowest level, the human directly operates on the input and converts it into an output. At the highest level, you have a version where the human actually does not even construct the tool which converts the input into an output. The human just gives broad instructions to a tool design, which in fact uses the data and constructs the tool which converts the input into an output. All of this might sound a little abstract now. We will give several examples and make this clear now. The first question before we do that, you should ask, why should you use machine learning at all, right? Machine learning seems significantly more complex than manual labor or tool usage. Why should we even use machine learning? The answer to that is, if you can use programming or human labor to do a task, you should not use machine learning. You should use simple programming or human labor. But there are several situations where programming or human labor will just fail. The main reason why human labor would fail is because it just does not possible to achieve the task at the scale or the speed or the cost that is available to perform that task. The common reason why programming might fail in performing a task is that you might not be able to express the rules that convert the input into an output using, say, computer programming language, or in some cases you do not even know the exact rules that transform the input into an output. So, these are all reasons why programming or human labor can fail at a task, but that is not sufficient for machine learning to succeed. For machine learning to succeed, we need one other thing, which is we need to have sufficient hope that machine learning can succeed. And one of the main reasons we think machine learning can succeed is because if it has access to data. If you have access to a lot of example data, then machine learning can reasonably succeed. In addition to that, it is also nice if you have some structural idea on the rule. Even though you do not know the exact rule that transforms the input into an output, you must have some structural idea on the rules. Right? So, all these points will make clear when we look at several examples now. Let us consider a very simple task first. Let us consider this, let us call this task password verify. Right? So, let us say you are Google now, and the task is to verify the password input by some human somewhere. Can this be performed? Can this task be performed at the level of manual labor? Conceivably, yes. That is, when someone types a password, the password gets sent to a server, and there is a human who is actually looking at the server and just checks the password and then sees whether the password matches the password on file and then gives authentication. It is in principle possible for a human to do it, but you can clearly see it is not possible in scale. That is, we will need billions of humans just to do password verification, which is not clearly possible, and humans are more likely to make errors and so on. Then okay, so this particular task is not suitable for to be performed at the level of manual labor. Can this task be performed at the level of, say, programming? And in fact, the answer is yes, because a human does not need to do this task of converting a password input into an authentication output directly. You can just write a piece of software, which in this case is the tool which just checks whether the password that is input matches the password on file, and if it does, it gives the authentication that, well, you can now log into your ID, or if it does not match, then it can say, well, authentication is denied. Right? This is a particularly simple piece of software that a human can directly design and directly write. There is no need to go to a higher level of complexity or abstraction where a human does not even directly write the tool, but because a human can easily write the tool in this case and can easily create the tool for solving the problem of this particular task. So, this is an example of a task which is not suitable for manual labor, but it can be solved using programming. Because it can be solved using programming, there is no need to even consider going at the level of abstraction of machine learning. Okay. Right. Let us consider another task that we just discussed now, that is the task of face detection. In this case, the input, let us imagine the camera itself as let us say you are the camera itself. What is the input and what is the output? Well, the camera has to take the image as the input, and it has to say whether, well, this particular image has it a face, does it have a face or not. If it has a face, where is the face? It should that is the output of this particular task. Can a human do this? Conceivably, once again, yes, a human can do it. That is, whenever you take your new Canon camera and you focus on a group photo, that particular whenever you press the button, whenever you are about to press the button, that particular image is sent on a server to, let us say, where there is a human looking at all the photos that are about to be clicked, and he would just go and draw boxes on those images. and those boxes are then somehow conveyed to the camera, and then the camera once again displays the box. It is conceivable, it is possible to do it, but it is clearly not feasible or efficient, right, because there are just not enough number of humans to draw boxes on all possible images. Okay, so that rules out manual labor. Can this be performed using programming? By that we mean that there is a human who writes a piece of software directly onto the camera, and what is this software supposed to do? Well, this software is supposed to take, or let us say a programming function which is supposed to take an image as input, and it is supposed to output the location of the faces in the image. Is this possible? I mean, can a human write a program which will do this? Immediately you can see that it is not straightforward to write a function which does this. Why is that? Because while humans have an idea of what constitutes a face, they cannot really write it in a mathematically precise way what aspects of these pixels in an image constitute a face and which does not constitute a face. You can easily, let us say if you are teaching the concept of a face to a baby, you will be able to easily do that, right. You can point to a baby and say this is a face, this is not a face, this is a face and this is not a face, and the baby would pretty quickly understand it, that these are faces and these are not faces. And when you give to the baby an image containing several people, the baby can easily identify where the faces are in that image. So that is, you know what a face is. It is just that you cannot convey that idea to a computer efficiently, because computer does not look at it. As far as the computer is concerned, every image is simply a collection of pixels. The idea of a face cannot be conveyed efficiently to a computer which just knows pixels. Even though there clearly exists a function which can do that. There exists a function which can take in an image which is just made of pixels and say where the faces are. There clearly exists such a function, but just that a human cannot directly write a function because he is not able to convey the idea of a face to a computer directly. So this rules out programming also. Now this is an example case where machine learning can make a huge advantage, because here the human does not need to even know, does not need to exactly convey the idea, the exact tool, because the human is not actually building the tool. The human is just giving the broad paradigms of the software design, and the software is not directly built by the human. Of course you need lots of data, and this is one example where face image data is practically unlimited on the internet. So there is no dearth of face data. So you have lot of hope of success with machine learning, because there is lots of face data, and humans do not need to exactly, they do not have to build the tool from scratch, because they do not have to write the software themselves. They only have to give inputs to a software design, which is what creates the software that converts an image into a face. So here is a summary of the problems of the face tagging task. That is, the problem with manual labor is that having humans check all faces of every image is just impractical. And the problem with programming is that expressing face or not face in code is just impossible. The case for machine learning is that you do not have to express this face not face in code as a function of pixels directly. You just have to give lots of images which are faces and lots of images which are not faces. This is sufficient for a machine learning paradigm to work. Here is one other final task that we will be analyzing, which is considered the task of weather prediction. Weather prediction, what is the input and what is the output of the task? The input of the task is a radar map, let us say. You want to predict the weather, or let us say you want to predict whether Mumbai is going to get rain or not the next day, right. That is your goal. And what is the input for making such a prediction? Let us say you have the radar map of, let us say, the entire Arabian Sea, Bay of Bengal and India and so on. So you have the radar map of containing the information about the wind, about the moisture and all that. You have that as the input for you, and you want to predict whether tomorrow Mumbai is going to get rain or it is going to be sunny. That is the goal. And in fact in this case It is not even possible for humans to do it because humans do not know, given their radar map, whether it is going to rain or not, because there clearly exists such a function because physics says that there exists, because whether it is going to rain or not tomorrow clearly depends on the moisture, the wind and the other conditions that are prevalent today. So, there clearly exists a function which is what is implemented by nature when it decides to rain or not the next day, but just that humans do not know this function. So, in fact, in this particular case the human cannot actually, this particular problem is not able to be solved using manual labor because the human does not know the function which maps the input to the output. It is for that exact same reason programming will also fail, because if the human does not know what transforms the input to the output, there is no way he or she can convey that idea to a computer. So, programming this particular task cannot be solved at the level of programming as well. At the level of machine learning though, immediately it becomes possible, because the only requirement is that there exists a rule which transforms the input, which is in this case the radar map to whether it is going to rain or not the next day. And we know such a function exists because nature itself is implementing such a function. You do not have to know that function, you do not have to be able to convey that function to a computer and so on. So, the only thing you need to know is that there exists such a function, and in fact you know that exists. So, you do not have to worry about the problems that you encounter with manual labor and programming. Once again, the human just has to give the broad parameters of the software design, which in turn designs the software and uses some additional data of weather maps and creates a software which will convert the, let us say, the local radar map into whether tomorrow you are going to get rain or shine. So, this is another example of a case where machine learning is, this is an example of a good machine learning task, that is you cannot solve it with manual labor and you cannot solve it with programming also, but you can solve it with machine learning because there is hope for solving it with machine learning because there is lots of weather data available, and in fact most weather prediction systems do use machine learning in some way because of the immense amount of availability of weather data, and it is just not possible to predict weather using either manual labor or with just simple programming. So, with that I think you have a broad idea of what is machine learning and when you can apply machine learning. Then the question becomes, okay, where is machine learning being used? This section is mostly an advertisement of machine learning. Machine learning really does not require an advertisement considering the ubiquitous nature of it, and you just cannot go even a few minutes without encountering machine learning, but I will still go ahead and do that to let you know where all machine learning can be found. This is by no means an exhaustive list. There are several applications. Any application that you can think of has a potential use case for machine learning. So, this is by no means an exhaustive list, but this is a couple of examples that you can find machine learning in. Let us get the easy example out of the way first, which is an example that you encounter every day in your email inbox. Any reasonable inbox system like Gmail or Hotmail or any reasonable email system actually has a very good spam classifier in it. That is, every time you receive an email, the mailbox itself classifies that email as either spam or a regular email, and all the spam emails get into a spam box and all the regular emails just go to the inbox. In fact, this is one of the biggest success cases of machine learning, where machine learning has largely solved the problem of spam. As of even, let us say, 10 years ago, spam was a huge problem. That is, for every valid email that you get, there would be 5 to 10 spam emails which you would have to sift through to get to your regular email. But machine learning has tamed the problem of spam, and it has successfully done so. And why was this problem not, we can ask the question, okay, this is a machine learning task, why can't it be solved using human labor? Yes, it can be solved using human labor, but the problem with human labor is that it has the problems of scale and speed. The problem with programming is once again similar to the problem with face detection, where given an email, how do you say with a program that this particular email is spam or not a spam, because spam has a variety of characteristics. You can't do any simple function which just write a function which takes in an email and says whether it is spam or not. There is no simple function which can do that. Given an email you can say whether it is mostly you can say whether it is spam or not, but it is just not possible to convey this idea to a computer. But once again this is easily solved using machine learning, because you do not need to convey that idea at all. The only thing you need to give to the system is lots of data, which in this case boils down to giving it examples of lots of spam emails and examples of lots of non-spam emails. That is sufficient for the machine learning algorithm to design the tool that actually takes in these inputs which are emails and classify them as whether spam or not a spam. Okay. So, and one other example that you encounter every day is in your shopping cart. Whenever you go to Amazon and you say you buy a couple of books, so you will often see this extra thing which will say customer who bought this item also bought these other books. This is an example of what is called a recommender system, and recommender systems are another important task that is often solved using machine learning. In fact, when you go to YouTube or when you go to Netflix, this is again brought to its fore. When you watch a TV show, then you get a bunch of other TV shows that says people who watch this TV show, who like this TV show also like these TV shows. And similarly for YouTube, when you watch one particular news video, it will automatically recommend other videos which other people similar to you have watched. So this is how does machine learning do that. We will not be attacking that particular problem in this course, but that is an example of machine learning. Once again, can this be solved using humans? Potentially yes, that is a human can just do a psychological analysis of each person and then say okay, this person likes these videos, so this is a type A kind of person, so he will like these kinds of videos also. But you can clearly see this is not scalable to all humans, and it seems like a wild violation of privacy. And this cannot be done using programming, because you might there is no clear rules on which video someone else is going to like, given that he has watched these other videos. Even though you might have a hunch, it is difficult to translate this hunch into at the level of programming where you can convey that to a computer directly. But to solve this task at the machine learning level, you need neither. You just need to have examples of several examples of videos that this person has watched and other people have watched, and you just use that to come up with a tool which takes in the input, that is your history of videos that you have watched or books that you have purchased, and predict future videos that you will like or future books that you will like, right. So this is an input output which is not possible efficiently with humans and not at all possible with at the level of programming, but it is possible to solve this particular problem also at the level of machine learning. Another example that you might have encountered very often is your smart assistant, is your Alexa, it is your Siri, it is your Google Assistant and so on. All of these use machine learning as a very integral part, right from the part that when you speak your sound waveforms are converted into text, and which in turn is converted into commands. Right? As far as the computer is concerned, a sound waveform is just a waveform. It's a time varying signal. That's it. It is not. It is possible to solve this at the level of humans, where you hide a small human inside every smart speaker, and that small human decides whether what you are saying is Alexa or not. But you can clearly see the ridiculousness of it, but you cannot. This solution is simply not scalable. Well, can you solve this problem using programming? Once again, you run into the same problem that you had with face tagging, with spam detection and so on. But while you might be able to hear a sound and say whether that sound was Alexa or not Alexa, how do you do that at the level of programming? How do you write a program? How do you write a function which takes in a time varying signal as input and outputs whether the word Alexa was said or not said in that particular signal? It is immediately the problem is that you cannot convey the idea of the sound Alexa to a computer efficiently. Once again, machine learning has no such issues with doing that, because you only need to give several examples of Alexa and several examples of not Alexa, and the machine learning tool design will automatically do the job for you, and it will convert it will construct a tool which will convert your input audio into whether the sound was Alexa or not Alexa. Right. And of course, smart assistants use ML even more than this, that is they do not just convert sound to text, right. So, they also convert text into commands that can be actually performed by the smart assistant, right. Let us say if you said increase volume by 10%, let us say that is what you said, it has to first convert what you say, that is increase the waveform corresponding to increase volume by 10% into the words increase volume by 10%, and then it has to detect that the command that you have given corresponds to increasing volume by 10%, because not everyone might say it in the same way. They might say things like raise sound by 1 point, right. They might say, which might pretty much mean the same thing colloquially, but how do you convert all of that into a reasonable command that an assistant can perform on the mobile or on any system, right. So, machine learning is used for that as well. Machine learning is used for converting the text into a command that can be performed by the assistant. And one other example that used to be all the rage, that used to be one of the main motivations behind developing machine learning itself, was building robot artificial intelligences. If you have seen any movie like Terminator or Robocop or iRobot or anything like that, you know that these used to be all the rage in pop culture, and they are still one of the main goals of machine learning, but machine learning has found so many other successes that it is not the only goal anymore. But it is still useful in several robots. For example, when you build let us say in this case this is I think the Perseverance rover in Mars, right. So, when you build a robot for let us say operating in Mars, it is just not possible for humans to do the job, simply because it is going to take 10 to 15 minutes for just the radio signals from Mars to reach Earth, right. So, you cannot remote control the robot using it is just not possible. So, there must be, you can do some level of programming, you can perhaps pre-build a route of let us say you want the rover to move from crater A to crater B, you might have already computed the route and said, okay, broadly this is the thing that you should follow. But there are several unexpected things that can happen, and programming just cannot handle it. So, for example, in this case an input might be some environmental situation and output might be what action to take, right. The action might be, let us say, move forward, move left, stay there, switch on your parachute, or huddle up, or there might be several actions that a robot can do. That might be the output, and the input would be the current environment, right. Once again, it is not possible to hard code program a program for all possible variations, simply because you do not know what is going to happen. But machine learning can handle this to a certain extent, because you just need to give enough data to it so that it can effectively find the right or a good thing to do for every possible situation. And one other recent huge success of machine learning has been in games. We know that in chess already in the late 90s there was a human built chess system which beat the best human, just Gary Kasparov. But these systems have had even more success in recent times, where, for example, Go was supposed to be an impossibly complex game that computers were not supposed to beat for the next 10-20 years, but suddenly immediately this thing happened quite recently, in just a few years ago, where a Go playing system which was primarily built around machine learning beat the best human Go player. And this is eventually going to happen for pretty much all games with complete information. Artificial intelligence or machine learning agents are the most powerful players. And in practical industry applications, machine learning is used in, for example, in things like marketing, in social media marketing, where you might have a limited budget. Let us say you have a budget of $100 and Facebook is asking $10 for a single ad. That means that you have a budget for 10 ads, but whom do you advertise to, right? This is another, if you are a brand, you have limited budget, but you want to reach as many people as possible. How do you decide whom to advertise to so that you can maximize your impact? So, this how do you market across, let's say, some social networks, how do you market across Twitter or YouTube, or how do you do this efficiently is a very complicated question, and machine learning has made huge strides in solving such problems. So with that, I think this helps you to understand what is machine learning and when can you apply machine learning, and finally you also know several areas where machine learning has been applied to. So this gives a brief introduction into machine learning. We will jump into the nitty gritty details of what makes machine learning work in the next section. So for this, that is all we have for this video. Thanks.